And welcome back to another LeetCode video. Today we're looking at LeetCode 2807, insert greatest common divisor into list. This is a medium linked list problem, and let's just read through the description to understand what it's about, and then we're going to come up with an approach on how to solve it, space and time complexity, and then we're going to implement the solution. So we're given the head of the linked list in which each node contains an integer value. Between every pair of adjacent nodes, insert a new node with the value equal to the greatest common divisor of them. Return the linked list after insertion. The greatest common divisor of two numbers is the largest positive integer that evenly divides both numbers, right? And here we have an example, and we can see, okay, this is the 18 is going to be the head of our linked list, and then we have a next reference to the next node, and that's how they are connected. Cool. And then we insert the GCD of 18 and 6 between 18 and 6. In this case, the GCD is 6 because 6 divides 6 and 6 divides 18 evenly. Cool. And yeah, and then we just continue with that. So I think, let's look at the constraints. We have at least one node in the list. That's good. And the node values are all going to be positive. Good. Okay, cool. So I guess for this problem, you kind of have to know how to compute the GCD. Computing the GCD is a very common thing in many LeetCode problems, and at some point you will just memorize it. There are different approaches. I think there's even a Python built-in function to compute the GCD. But if you want to compute it by foot, let's just implement this. So if you have two numbers a and b, and you want to compute the GCD function for them, the algorithm is quite simple. So you iterate while b is not 0, and then what you do is you swap a with b, and b becomes a modulo b. And why is that so? Well, math. So if you want to, I encourage you to look into why this works. But this is pretty much the algorithm that you will memorize it at some point. You can also do a brute force approach, but this one is much more efficient. I think it's only a log log time complexity and something log of a and b, something like that, or log of yeah, so I think the log of the larger number. That's pretty much it. So yeah, well, that's going to be a component that we just assume that we know. And then for the rest of the problem, to solve it, so we will have to return the list at the end, right? So we might as well just add our little return statement here. And when we iterate over a list and we want to insert something between two nodes, it would be quite obvious that we're going to have a previous node, and we're going to have a reference to the current node, since our list node object doesn't have any back references. It has forward reference to the next node. And we'll initialize with the previous node being none and the current node being head. Now, we're just going to iterate over the entire list while the current node is not none or not nil. And well, iterating will work like this. So we're going to set previous going to be the current, and the current is going to be the next. And now we need to take care of the insertion, and inserting the GCD between two nodes only makes sense when the previous node exists, right? So in the first iteration of the while loop, previous is going to be none. So we have a little check here. So if previous exists, well, how do we, well, we need to first determine the value of the new node, right? And since previous is guaranteed to be not nil, and same applies to current, we can get the value from the previous node and from the current node and compute the GCD with our little helper function up here. And now we need to insert a new node with that value, and that's actually a one-liner. So what we can do is previous.next equals, well, we're going to use a new list node object. And list node takes in the constructor the value and a reference to the next node. Very nice. So just plug in val and current, and yeah, that's the whole thing. And The only thing left to do now is to do a runtime analysis. And obviously we have, let's assume the length of the list is n, and we're iterating over all elements. So that's going to be O of n times calling the GCD function. So we'll have something the order of n log m time, and base complexity, well, we're creating n minus 1 new nodes, so that is also in the magnitude n base. N is the length of the list. M is max, because that's what we're going to plug into the GCD function here. So let's just run the test cases to see if we made any syntax errors or grave logic errors, but it seemed like we did. And now let's submit this. And it passes all of the tests. So yeah, although this problem is marked as a medium, I think it should really be an easy one. GCD is something that you memorize.